This experiment will demonstrate some of the qualitative tests that can be used to identify organic functional groups in unknown solutions. Watch the video to see how to carry out tests that can be used to identify carboxylic acids, phenols and alkenes, and the expected observations. This experiment will demonstrate some of the qualitative tests that can be used to identify organic functional groups in unknown solutions.
So the first test I'm going to do is a test for a primary or a secondary alcohol. So into my beaker I need to get some hot water from the kettle.
First, you need to make a water bath. Half fill a 250 centimetre cubed beaker with hot water from a kettle. The water should be about 60 degrees Celsius.
Then I'm going to add 2 different chemicals to a test tube. The first one is going to be some dilute sulfuric acid. I need approximately 10 drops. And then secondly, I need some potassium dichromate, about 4 drops.
Potassium dichromate acts as an oxidizing agent. It is an orange solution.
And then to that, what I'm going to do is add some of the sample that I want to test. In this case, I've got butan-1-ol. This is my primary alcohol. And I'm going to add 5 drops of that. I'm going to put the test tube into the beaker for 5 minutes. So you can see here the colour change has turned from orange to green, showing that the primary alcohol has been oxidised.
The alcohol is oxidised by the potassium dichromate, causing the colour change. This occurs for both primary and secondary alcohols, but not tertiary alcohols.
I'm testing now for haloalkanes. What I need to do first is to put a small amount of ethanol into a test tube. And to that I'm going to add just a small amount of the substance that I'm going to test. So in this case I'm testing bromobutane. And I'll pop that in a hot water bath to warm. What I also need to do is add some silver nitrate into the water to warm up.
Pipette the silver nitrates into a separate test tube and place it in the water bath.
So now I'll add the contents of one test tube to the other. So I'll add the silver nitrate to the mixture containing the haloalkane.
If the solution contains a haloalkane, the silver ions will react with the halide ions to form a precipitate.
So you can see here a precipitate has formed. If we look at it in front of the white tile, you can see it's a cream precipitate. The colour of the precipitate formed will depend on the haloalkane. So a chloride would form a white precipitate, the bromide forms the cream precipitate, and the iodide forms the yellow precipitate. This is the test for the presence of a carboxyl group. So into a test tube, just put some sodium carbonate solution. And you add some of the chemical that you want to test. In this case, I'm using salicylic acid.
Salicylic acid is a type of organic compound that contains a carboxylic acid functional group.
And if the carboxyl group is present, you should see some effervescence.
The sodium carbonate reacts with the carboxylic acid group present in salicylic acid to produce carbon dioxide gas.
This is the test for an alkene. I'm going to add some of the substance to be tested to a test tube. In this case, this is cyclohexene. And you can see that it's colourless. In this test tube here, I have some bromine. You can see the colour of the bromine is a yellow or an orange colour. If I add some of the bromine water to the cyclohexene, just a few drops, you can see that the bromine water is decolorized and changes from yellow-orange to colourless.
If an alkene is present, the bromine adds across the carbon double bond. This causes the yellow-orange colour to disappear and the solution to become colourless.